Hello everyone, let me start by introducing myself. My name is Laiba Khalid and this is my Drilling Engineering 2 assignment. The topic given to us is well control. The best works are done together with the team, and my team members include Elnur Shahbalayev, Asem, Ameen, Nurul, Izzah, and Koo Jun Min. The main objective of this assignment is to explain the meaning and types of well-controlled equipment. The second objective is to know how through simulation well-controlled procedures work. And last but not the least, to differentiate between the driller's method and the engineer's method to know which one's the best. So what are well-controlled equipments? They are a series of equipments that actually detect the unplanned influxes of the formation fluid into the well. The function includes to prevent, divert, and control the flow of the fluids from the well, also to purge formation fluid from the well, also to separate formation fluid from the drilling fluids. There are many types of well-controlled equipment. For example, blowout preventer, and ram preventer, annual preventer, rotation preventer, and diverters. What's the difference between the driller's method and the engineer's method? Well, the details will be covered later, but for now, to brief you, driller method is one of the methods that is used to kill the well with a constant bottom hole pressure. It includes a two and separated circulation of the drilling fluids. While engineer's method, or better known as weight or weight method, it consists of one circulation. The experts are opinionated on choosing the best method to circulate an influx out of the wellbore.
Hi, my name is Koo Jun Min, and for my part, I will be explaining about the main well control equipment. Now there is three main well control equipments, which is the diverter, accumulator, and the blowout preventer. So first is the diverter. Now, when drilling up to a depth of 2,500 feet with the presence of gas, the blowout preventer is not recommended as it will fracture due to the low strength of the top hole. Therefore, the diverter is introduced. The diverter system has a design which will close before the ejector valve opens. This is to minimize the back pressure on the well. The best practice for a diverter vent line system is that it should have the following options, which is to allow the discharge downwind of the rig. So if the diverter fails, it usually fails at the flow line connector seal. This is because that is the weak point of the diverter. If the diverter fails, the safest option is to evacuate the rig. So moving on is the type of diverters. Now the first type is conventional diverter. As can be seen from the example picture from the side, this is the conventional diverter, and the maximum pressure that this diverter can handle is 1200 psi and the normal pressure of 750 psi. So the second type of diverter is the insert type diverter. Now as we can see from the photo here is that the difference from the conventional diverter is that there's a drill pipe inserted in the middle of the diverter with the presence of standard packer and the insert packer. So this type of diverter is used to close and seal specific range of pipe diameter. The insert packer is removed during the run-in hole or the POH pull-out hole with the bottom hole assembly. Now this diverter is better than the conventional diverter as it is faster to close the well. This is because of the much smaller closing volume. Now moving on is the diverter testing requirements. Now, the diverter should be tested weekly to ensure it is in proper working conditions. Now, the test requires the diverter to be fully open and fully closed. So, moving on is the pressure test. During the pressure test, there should be no visible leakage at the packer and the flow line seal. The pressure test should be done annually or during packer replacement. Now the second main well control equipment is the accumulator. The accumulator is a device which potential energy is stored in the form of compressed gas or spring. Now this energy is used to exert force against the relative incompressible fluids. Now the pictures beside here, we can see that this is the accumulator unit. Now the accumulator unit consists of electrical power supply, uninterrupted power source, hydraulic power unit, and human-to-machine interface. Now this is to process, communicate, and display the command and status data. Now the accumulator is the main control unit of the blowout preventer. It is used to seal, control, and monitor the oil wells from high pressure and to prevent the release of crude oil or natural gas from the oil wells. So moving on is the API requirements for the accumulator system. Now, the usable fluids for the accumulator system needs to be recoverable between the pressure of 3000 and 1200 psi. The reservoir capacity needs to be at least 2 times the usable fluids of bottles. Now, with each of the accumulator bottles, the pump must be capable of closing one annulus on the minimum pipe size, opening the HCR valve, and maintaining the pressure of 1200 psi in the system within 2 minutes. Now, each pump system should have 2 overpressure protective devices, which is the pressure switch set and the pressure relief valve. The electrical pump for the accumulator system is kick on at 2700 psi and the kick off is at 3000 psi, while for the pneumatic pump, the kick on is at 2550 psi and the kick off is at 2850 psi. So that is all for my part. Thank you.
Hello, my name is Asem with student ID 19000918. Today I'll be talking about blowout preventer. So blowout preventer or BOP is a huge equipment which weighs up to 400 tons. Its function is to control and seal the hydrocarbon wells. In other words, it's used to prevent uncontrolled flow of oil and gas due to a kick, which might lead to an event known as blowout. This blowout preventer may be used in both offshore and onshore rigs. So first let's talk about classification of BOP. As you see in this figure, the class of this BOP is 6, A3, R3, 20K. So 6 stands for the number of annual preventer, R stands for the number of ram preventer, and 20K stands for the number of rated working pressure that this BOP can handle. And 6 stands for the total number of the equipment installed in the BOP. So let's assume we have A2, R2, then it will be class 4, not 6, since the total equipment installed are 4. Now let's talk about BOP rams type. So it's starting with fixed pipe ram, which is sealed around the pipe of fixed size, and then we have variable bore rams, which is sealed around pipe with more than one size and only within the range of its specification. And then we have blind rams, which is sealed around open hole, and then we have shear rams, which is cut strange without making the seal, sorry. And then we have blind shear rams, which is cut strange and seal the well. So moving on to the second slide. So have a look at this table first, down on the right side. The class of BOP is chosen based on the provided rated working pressure. When the provided condition requires a BOP with, like, let's say 15,000 rated working pressure, then the selected BOP would be class 5. And let's say the condition requires a BOP with 2,000, 3,000 rated working pressure, then the class will be 2, and so on. And then have a look at the other figure, the one on the left side. For the selected BOP, all the elements must be higher than the maximum anticipated surface pressure of the well. For example, for simplification, let's assume a well that has around 11,000 psi anticipated, then all elements must be at least 15,000 and above except for the annular. As you see in this figure, all the elements of the BOP has minimum of 15 and above except for the annular. And now, as you see in this slide, we have two pictures. The first one on the left hand side is the manual gate valve, and the other one is the HCR gate valve. So what are these used for? For surface BOP stack, it comes with one manual gate valve and one hydraulic control remote, HCR valve. Whereas for subsea BOP stack, it comes with two HCR valve with fail-safe feature. Manual gate valve usually located adjacent of the BOP or inside, whereas HCR is installed downstream of the manual valve. Both seats exist for kill line and choke, and must have rated working pressure that is same as the ram rated working pressure of the blowout preventer. That's it for my part, and thank you so much.
Moving on to the next part, there are two main methods for killing a well, but only one method will be selected for a well. The two methods are driller's method and engineer's method. For driller's method, it is a method that involves two circulations. In the first method, only influx is wanted to be removed by pumping the original mud. Kill mud doesn't need to be prepared before the first circulation starts, as it will only be used in the second circulation. The calculation of kill sheet is also no need to be prepared before the circulation starts. The kill mud can be prepared while the first circulation takes place. In the first circulation, it only aims to remove the influx out of the well. Once the influx is out, the well is shut in again. As the first circulation ends, the kill mud will need to be ready. The kill mud will then be pumped while displacing out the old mud for the second circulation. During second circulation, there is no more gas in the well because gas has been removed during the first circulation. The second circulation aims merely to replace old mud with the kill mud. Meanwhile, for the engineer's method, which is also known as wait and rig method, it involves only one circulation. In this method, the operation will need to wait for the kill mud to be prepared by wetting up the kill mud first before the method can be started. Only when the kill mud is ready, the kill mud is pumped into the well at the same time the influx is being circulated out up the annulus.
In case of kick, wells need to be killed. There are two methods for killing the well. First is driller's method, and the second one is wait and wait method. In driller's method, there are two circulations, while in the second one, there is only one circulation. Let's check them more detail. In driller's method, first the influx is removed by pumping original mud. At the same time, kill mud is prepared. Once the influx is out of the well is shut in. In the second circulation, kill mud is pumped and the old mud is being displaced. Driller's method is taking longer, but it is safer than wait and wait method. As you can see here, first the normal mud is pumped and the gas is removed. As you can also see that the gas is expanding as it goes up. The circulating pressure drops, and the only job now is to remove the old mud with kill mud. Using old mud first gives time to calculate and make better kill mud. On the other hand, we use wait and wait method when the open hole volume is greater than the string volume. That is because it gives low shoe pressures while putting less stress on surface equipment and less time on the choke. However, if open hole volume is less than the string volume, wait and wait method has no benefit over driller's method. So what happens is, as soon as kick happens, kill mud is pumped fast, and we can see that dP is staying constant while the Cp increases a lot and reads FCP, which is final circulating pressure. However, after the gas is removed, FCP will be 0 and dP will return back.
Now let's look into the difference of these two methods that can be seen in the table. As per mentioned before, driller's method requires two circulations for the process that may take longer time, which can cause more damage to well control equipments. Meanwhile, the engineer's method requires less time for the process as it involves one circulation, which causes less damage to well control equipment. The next difference for these two methods are the operation for driller's method can start immediately without requiring the kill sheet first or preparation of kill mud, as it can be done during the first circulation because the kill mud will only be used in the second circulation. However, the operation of engineer's method can only be started once the kill mud is ready. Next, as per mentioned just now, in driller's method, the kill mud is pumped in the second circulation after the influx is removed first in the first circulation, which is different from the engineer methods, as kill mud is pumped whilst influx is circulated out up the annulus. As influx is removed in first circulation in driller's method, it minimizes the risk of gas immigration, but for engineer's method, there is risk of gas immigration as gas could migrate while waiting to mix the mud before the operation can start. Other than that, driller's method requires less calculation than engineer methods, as engineer method will need to fill the kill sheet with calculation before the operation can start. Last but not least, the differences can be seen in the case of open hole volume is less than the drill string volume. For engineer's method, the kill mud will not reach the bed and annulus faster than the gas reaching the shoes. Hence, the kill mud will not help to reduce the shoes pressure as the gas will reach the shoes first before the kill mud reach the bed and the annulus. However, in the driller's method, while dealing with the influx in the first circulation, there is no kill mud that can be used to lower down the shoes pressure. Hence, the shoes pressure is bigger with driller's method as compared to the engineer's method. That will be the end of our presentation, and here are the list of reference that we use for our group project. Thank you.